Okay guys, so in today's video we're going to be tackling the first aspect of motion in physics. This is a very critical topic in physics, so stick around to the ending of the video, as in your forthcoming exam there's a 100% chance of questions coming out from this topic. So today we're going to be talking about equations of motion. So now there are three basic equations of motion. So this is v is equals to u plus at, s equals to u t plus 1 over 2 at squared, and v squared equals to u squared plus. Now let's define the variables we have here. V is our final velocity, whereas u is the initial velocity. A means acceleration and t means time. So s refers to distance, not d. So here we use s as this. Let's define this quickly. Velocity is the time rate of change of displacement. Acceleration is basically the time rate of change of velocity. We're going to be going over some questions on. Alright, so now question 1. So a particle starts from rest and moves with a uniform acceleration of 4 meters per second squared. What is the velocity after covering a distance of 8 meters? So the first thing I would like to do is to take out our parameters. So I'll take out the things we are given in the question and what we are supposed to look for. So now they said a uniform acceleration of 4 meters per second squared. So we'll take our acceleration as 4 meters per second squared. Velocity. So we are looking for velocity. So let's say v is the unknown here. So our s here is what? 8 meters. So in the question they specifically say that it started from rest. So therefore u is equals to 0. So at the ending of the video, I'll be showing you all the rules that you need to know so as to not to make mistake in your solvings. So we know that we can apply this formula, right, to get our answer. So v squared is equals to u squared. So since u is already equals to 0, so there's no need to mind that. So v squared is equals to 2 times our a is 4 and our s is 8. Remember, it's in the right unit, it's in meters. So we just go straight. So v squared, so we root both sides, is equals to 2 times 4, that's what? 8 times 8 times 64. So root of 64, v is equals to what? 8 meters per second. So that's basically our answer. So next question. So this next question is a little bit more tricky, so pay attention. So tourist is traveling at 120 kilometers per hour and sees a broken truck at the middle of the road and immediately applies his brakes and comes to a stop with uniform retardation in 20 seconds. What distance does the car drive after the brakes were applied? So now you may looking at this question, you might want to cry and say, oh god, what the heck are they giving me here? So now I'm going to break it down and I'm going to show you how we can solve it and get our answer quickly and accurately. So now whenever I'm solving a question on motion, I like to visualize it. I like to see like I'm in that action speed. The speed here is what? So we can use v. Speed here is what? 120 kilometers per hour. So this is not the SI unit for speed, but let's just keep on going. You understand, right? Applies this brake, comes to uniform retardation in 20 seconds. So you might be asking, what's this retardation? Retardation is reduction in velocity with time. So it's just actually like the brother of acceleration. But time taken is 20 seconds. T is equals to 20 seconds. Now we are looking for the distance the car covered when the brakes were applied. So now S is equals to velocity times time. But in this case, some people just go, yeah, 120 times 20. Ooh, got your answer, 2,400. But that's actually wrong. Remember, this is not in the SI unit, this is in kilometers per hour. So whenever you want to change something in kilometers per hour to meters per second, you basically times by 10 over 36. 10 times 120 divided by 36. So that's 33.33. Now times the time. The time is 20 seconds. It's in the right unit, so you can just multiply that straight. That's equals to 66.7 meters. So this is our answer here, and that's basically how we solve it. Alright, so you have made it so far to the end of the class. So now the important part, let's go to some of the notes. So when an object moves or accelerates from rest, its initial velocity is 0. Take that. When a body comes to rest or stops, its final velocity is 0. When a body velocity is constant or not changing, its acceleration a is equals to 0. So you have to take note of these three main notes. So this will help us in our further solving. And please subscribe to that channel so that you get to see my new video on velocity time graphs. And if you like this kind of content, please share. Thanks. I hope you have learned something or two. Please comment on the comments so that I'll know maybe if there's any mistake or if you want to add any other contribution. Thanks. Peace.